Hi friends, today we will see the factor theorem of the polynomial equation. A polynomial equation of qx, suppose this is a polynomial equation, is divided by px completely if qx divided by px is divided completely and the remainder is 0. So, or alternatively you can say px is a factor of qx. Px is factor of qx. So, what the theorem is? Theorem is let qx is a polynomial equation, polynomial of degree greater than 1 or to be a real number such that PA means remainder is equal to 0, then x minus a, that is a divisor is a factor of px. So that is what is the theorem is, or we can say like qx is a polynomial of degree greater than 1 or to be a real number, means degree either it should be 1 or to be a real number, such that PA means remainder is equal to 0, then x minus a is a divisor, is a factor of PA. Or we can write down this thing like this: if x minus a is factor of px, then remainder PA is equal to 0. So that is what we have learned in the remainder theorem also. Now let us see how to prove that. And like if this can come to you to prove, like we have seen dividend is equal to quotient multiplied by divisor plus remainder, that we studied in earlier class. Let quotient is q is equal to qx is a quotient, and px and divisor is equal to x minus a. So when and dividend is a px. So this equation will be px is equal to qx multiplied by x minus a plus, say, remainder is equal to pa, as we have studied in the remainder theorem, plus pa. So if x minus a is a factor of px, if x minus a is a factor of px, then remainder will be 0. That we already know. So that is condition number 1. If px or x minus a is factor of px, then pa is equal to 0. And by the remainder theorem, if we see px is fully divided by x minus 1, then remainder, if px is divided by x minus 1, then remainder is pa. If px is divided by x minus a, then remainder is pa. Simply x minus a is equal to 0, so x is equal to a, so this a value has to be replaced here. So with this two theorem, we can prove, like, if it is completely divided by, then pa is equal to 0. Such kind of a proving thing may come out for you in your exam, but don't concentrate, to my mind, you should concentrate on the thing, numerical problem. Let us quickly see the numerical problem on this thing. This I just tell you the proof. Like, one problem is, show x minus 3 is factor of x cube minus 3x square plus 4x minus 12. Here to show. So when x minus 3 is a factor of this, that means this equation is fully divided by, this polynomial is fully divided by this polynomial. So it is, we have to prove that if pa is equal to 0, then it is a factor of this. So, like, let px is equal to, you have to write down in the exam like this, minus 3x square plus 4x minus 12. If x minus 3 is factor of, you have to write down this way in the exam, then only you will get the marks. Factor of px, then p3 should be equal to 0. Here you find out the value of p3. You will see 3 cube 27, I am just directly going in. 3x square, 9 into 3 minus 27, 4 into 3 12, minus 12 is equal to 0. Hence, you write down x minus 3 is factor of write down this complete equation. Similarly, there are other thing can come, like I'll write down here only. Show that x minus 1 is a factor of x raised to 10 power minus 1. Similar way you have to solve x is equal to 1, like let us, it is a px. Then find out the value of p1, x at p1, because x minus 1 is equal to 0, so x is equal to 1. So that is how p1 you will find out, and here you will see 1 raised to power 10 1 minus 1 is equal to 0. So that is how, but you have to write down in this manner in your exam. Okay. Now another thing, this kind of a small question will come, but remember the basic concept. Without actual division, like I'll write down, without division, prove that two x raised to power 4 minus 6x cube plus 3x square plus 3x minus 2 is exactly divisible by x square minus 3x plus 2. Here it is a little twist in the thing. Instead of factor, they have mentioned exactly divisible. Exactly divisible factor, it is all same because the remainder becomes 0. But the trick here is, here earlier whatever we have seen the polynomial equation divided by a linear polynomial equation having a degree 1. So whenever the linear equation is there, say x minus 3, you just equate it to 0. So x is equal to 3. Find out the value of px. If it is equal to 0, then it is a factor or exactly divisible. But here is a polynomial equation with degree 2. So what you have to do? You have to start, let px is equal to 2x raised to power 4 minus 6x cube plus 3x square plus 3x minus 2, and then qx is equal to x square minus 3x plus 2 equal to, by splitting method you have to break down this into two polynomial of having degree 1. How you will do that? You can write down x square minus 2x plus x plus 2 equal to, take x common from here, x minus 2 plus take 1 common from here, x plus, oh sorry, it is minus 3x, so it will be minus, so take minus 1 from here out, then it will be x minus 2. In this equation, take out x minus 2 out and x minus 1 out. So this equation is equal to this, of two polynomial, multiplication of two polynomial having degree 1. Hence, x minus 2 or x minus 1 or should be factor of px if qx is factor of px. What are you saying? This x minus 2 or x minus 1 should be the factor of px. Then only qx will be the factor of px. I'll tell you how. Let's take a simple example, say 16. The factor of 16 is 1, 2, 4, 8 and 16. Now if it is a 8, okay, 8 you can write down 4 multiplied by 4. So 4 is also factor of 16 and 4 is also factor of 16. Similarly 16 you can write down 8 multiplied by 2. So 8 is also factor of 16. So whatever splitting you are doing, so these two split alone itself should be the factor of px, then only qx can be the factor of px. So let us find out px minus 2, so 2. Here you will put all the values here, like 2 into 2 raised to power 4 minus 6 into 2 raised to power 3 plus 3 into 2 raised to power 2 plus 3 into 2 minus 2 is equal to, if you will solve this, is equal to 32 minus 48 plus 12 plus 6 minus 2 is equal to 0. If you do that, you can write it 0. So that means ki x minus 2 is a factor of px. That one part you have proved. Now find out p1. P1 you will write it down. Similarly, if you will solve this, it will be also 0. So how you will write down? You will write down, since x minus 2 and x minus 1 are factor of qx and px, hence qx is factor of px. Therefore, I am not writing down, therefore px is exactly divisible by qx. So that is how you have to write down the answer. So I hope it is clear. Let us take quickly another example. So look, it is in mathematics, it is just a wording. Some word here and there they will give it to you and they will ask. But if you are knowing the basic clear, like in remainder theorem or factor theorem, I told the divisor should be having degree 1. If it is having any other degree, then you have to use the split method to convert it into a degree 1. Now find value of a. If x minus a is factor of x cube minus a square x plus x plus 2. So again you will write down, let px is equal to this equation x cube minus a square x plus 2. Since x minus a is factor of px, then pa is equal to 0. Now you put the value of a here, so pa equal to a cube minus a square multiplied by a plus 2. So a cube cancel, a plus 2 and equate equal to 0 equal to a plus 2. So a is equal to minus 2. So remember the basic, that is how you have to do that. Let us see another example. Let's say here the determine the value of a for which two x raised to power 4 minus ax cube plus 4x square plus 2x plus 1 is divisible by 1 minus 2x. Again you will write down the same thing. Let px is equal to this, and since it is a completely divisible by this qx, then p is completely divisible by 1 minus 2x, hence pa is equal to 0. Now find out the value of a. 1 minus here 2x is equal to 0. So 1 is equal to 2x. So x is equal to 1 by 2. So you find out the value of p 1 by 2. In this value you will see one variable a. This one variable you have to solve this. One variable a you will see, and then whatever equation will come at the last, I'll tell you it will come something like that. 1 by 8 minus a upon 8 plus 1 plus 1 plus 1, that will be p1 by 2. You solve this equation and then equate it to 0 and find out the value of a from here. So answer will be a is equal to 25. So thing is same, only thing little bit twisting of the word, and you can check it also. You put the value of 25 here and again find out x is equal to 1 by 2. If this entire equation should give you a result to 0. So that is what way you can find it out, but you can cross check your answer provided you have got a sufficient time available in solving the question paper. Now let us see. Here another thing. So far we have seen find out the value of a or k. Find out value of a and b. So that polynomial, polynomial x cube minus ax square minus 13x plus b has x minus 1 and x plus 3 as factor. Now what will you do? Again you will write down same thing. Let px is equal to so and so so and so. If x minus 1 is a factor of px, then P1 equal to 0, and if this, since because it is given, so since x minus 1 is a factor of Px, hence P1 is equal to 0, and since x plus 3 is a factor of Px, then P minus 3 will be equal to 0. Now you will get two equations. When you find out P1 you will find out, you will get minus 12 is equal to A minus B. That is the equation number 1. And when you will solve out P minus 3, you will get the equation 9A minus B is equal to 12. Now you have got a two equation with two variable. So it is very easy to find out. Here you are seeing minus, here you are seeing minus. So you do one thing, you subtract one equation from another. Let me write down A minus B, so that it will be easy to A minus B is equal to minus 12. So left hand side to left hand side, A minus B minus 9A minus B is equal to minus 12, this, and minus 12. So when you open up, A minus B minus 9A plus B is equal to minus 24, B got cancelled, minus 8A is equal to minus 24, minus will get cancelled, A is equal to 3. And you can put this equation value of A here, you can get the value of B, that will be 15. So this is with the two variable. If the two variable are there, then definitely two factor will be given to you, and you have to apply the mind when you have to do addition or subtraction based on the what equation you are getting there. There are another thing, some complicated thing will come. Say 2x square 2x cube plus ax square plus 11x plus a plus 3 and is divisible by divisible by 2x minus 1. So again you have to write down the similar thing. Let px is equal to this. Since it is px is 2x minus 1 is a factor of px, then p, what you will find it out here, 2x minus 1 is equal to 0. So 2x is equal to 1. So x is equal to 1 upon 2. So hence p 1 upon 2 equal to 0. Put p x value 1 upon 2 here. Solve this equation. So in this equation, equate this equation to 0. You will get value of a from here. So let us look further more example. So that is what is in the factor theorem. Now let us take few more example with a different thing. So far we have seen when it is a factor and we are equating it to 0. Now if suppose ax cube plus bx square plus x minus 6 has x plus 2 as factor. Okay, so factor means this polynomial equation is completely divided by this and remainder is 0, but have remainder 4 when divided by x minus 2. So again you will write down, let px is equal to this equation. Hence, since x plus 2 is a factor of px, hence p minus 2. Why minus 2? Because it is a x plus 2 is equal to 0. So x is equal to minus 2. So p minus 2 is equal to 0. Put the value of p minus 2, you will get a equation which will be having a and b. So I'll straight write down, you can solve it a little. You are having a equation like minus 8a plus 4b is equal to 8. This is equation number 1 when you are equating it to 0. But have remainder of 4 when divided by x minus 2. So x minus 2, hence p2, as per remainder theorem, p2 will be equal to 4. So again put the value of 2 here in place of x. You will get an equation 8a plus 4b is equal to 8. This is what is the equation number 2. But in exam you have to write down, let px is equal to this. Since x plus 2 is a factor of px, hence p minus 2 is equal to 0, so and so. And it is given like when divided by px is divided by x minus 2, remainder is 4, then p2 is equal to 4, and solve it in a detailed manner, then only you will get a marks. Now these two equations you are seeing 8a and minus 8a, so add left hand side and right hand side. So minus 8a plus 4b plus 8a plus 4b is equal to 16. So that way 4b, this will get cancelled. 8b is equal to 16. So b is equal to 2. You can put the b value in any of the equation, these two, and you can find out the value of a, which will be equal to 0. So that is another twist and good example, because in this it was given ki one polynomial is divided by another linear polynomial and having a remainder 4. Every time we are saying ki equating to 0. Now if both x minus 2 and x minus 1 upon 2 are factor of px square plus 5x plus r, then show that p is equal to r. So again what you have to do, let px is equal to px square plus 5x plus r. Since x minus 2 is a factor of px, hence p2 equal to 0, and since x minus 1 upon 2 is a factor of px, hence p1 upon 2 equal to 0. Find out both the thing. With this equation, if you solve it, you will get 4p plus r is equal to 0, and with this equation you will get p plus 4r equal to 0. Now since this is 0, this is 0, so 4p plus r is equal to p plus 4r. Take p here, r here. 3p is equal to 3r, hence p is equal to r. So little twist in the question, but concept remains same. You have to just remember the concept, go what wordings are given in the question and appropriately, but don't forget to write down the complete thing which I told, let Vx and this thing whatever it is. Now there is another thing, if x square minus 1 is factor of ax4 plus bx cube plus cx square plus dx plus e. Now you see 5 more variables are there, a, b, c, d, e. Show that a plus c plus e is equal to b plus d equal to 0. Now here the divisor is having a degree 2. You can apply the factor theorem or remainder theorem only when the divisor is linear or having degree 1. So again you will write down, let px is equal to ax raised to power 4 plus bx cube plus cx square plus dx plus e, and qx is equal to x square minus 1. So that is equal to x plus 1 and x minus 1. This kind of a small formula you have to remember in mathematics, so as you will save the time, and more you will practice this kind of a thing, you will remember. Okay, hence p x plus 1 means minus 1 equal to 0 and p 1 equal to 0. Now put the value of minus 1 first. So p minus 1, you will get an equation something like that, a minus b plus c minus d plus e, that is equation number 1. And p1, you will get a plus b plus c plus d plus e, that is p1. And these two values are 0. So what you can do? You can add both the side, like here add p minus 1 plus p1 equal to 0. Left hand side you are adding and right hand side you are adding. So when you will add this, so let us solve this. A minus b plus c minus d plus e, add plus a plus b plus c plus d plus e equal to 0. So you are seeing d and d getting cancelled, minus b and minus b getting cancelled. So you are getting 2a plus 2c plus 2e equal to 0. Take 2 common, then it will become a plus c plus e equal to 0. So one part of this equation you have proved. Now in the second term, subtract. You added, you come to this. Subtract this equation 1 minus 2. So in next time you will do p minus 1 minus p1 equal to 0. Subtract, then you will get b plus d equal to 0. So that is what, but basic concept is same. You can go up to this portion even if you are not getting a clear idea how to solve this. It is not that difficult, but even if you are solving it in a systematic manner by writing down everything and covering every step, you will get some or other mark. So whatever you know, the biggest beauty of the mathematics, if you are solving the question half, then also you will get the mark. But steps, should be fully covered. No shortcut in the mathematics, please. Now, there is one questions we have seen. What must be added to an equation so as it is completely divided by so and so, so and so. So such kind of a equation or such kind of a problem are there in the polynomial also. I'll write down what must be added to x raised to power 4 plus 2x cube minus 2x square plus x minus 1, so that result is exactly divisible by x square plus 2x minus 3. Exactly divisible or result is a factor of this, any wording people can use. Again you will write down, let px is equal to this equation complete, x4 I am not writing down completely, minus 1, and qx equal to you always take divisor qx whenever it is having a degree of greater than 1. X square plus 2x minus 3, this you can write down x square plus 3x minus x minus 3 equal to x common, x plus 3 minus 1 common, x plus 3. So you are having x minus 1 and x plus 3. For applying the factor theorem or remainder theorem, you have to break down this divisor into a linear equation. Remember that very carefully. So now you are having a 2 factor. This is a factor of px, hence x minus 1 should also be factor of px and x plus 3 should also be factor of px. So now you write down, since qx is a factor of px, hence x minus 1 will be factor of px and x plus 3 should be the factor of px, hence p1 equal to 0 and p minus 3 equal to 0. But write down completely in your thing. Now the thing is, what should be added? Means this is not a factor. Sorry, I did a thing. So this breaking thing we have taken out. Now what should be added? Here you have to remember, since it is a divisor is of a factor degree 2, then the remainder will be having degree 1. If divisor is of factor 3, then remainder will be of degree 2. So remainder will always have a lesser degree than the divisor. So to be added, like here, let Rx to be added. Rx equal to Ax plus B to be added so as Px so as Qx or Qx is factor of px. Why ax plus 1? I want to tell you again, because here it was having a degree 2. That is why you will add ax plus 1. If it would have been only x minus 1, then you can say only one constant you add and you will get the thing. So remember, if it is having a degree 3, then you will add something like that, ax square plus bx plus c, something like that. Okay. So remember that. Don't confuse on this aspect. So like px is equal to, now let us say it is fx after adding up the rx, px plus rx. After adding this value, the fx is a factor of x minus 1 and x plus 3. So that will be equal to 0. So f1 equal to 0 and f minus 3 will be equal to 0. So with this equation, let us find it out. F minus 3 and f minus 1. So fx equation will be, I will write it down here. Fx will be x raised to power 4 plus 2x cube minus 2x square plus x plus 1 minus 1 plus ax plus b. Now f1 will be, put this 1 here, 1 raised to power 4 1, 1 plus 2 minus 2 plus 1 minus 1 plus a plus b. So this 2 get cancel, this cancel, a plus b plus 1 equal to 0. There is a one equation we have got. Or a plus b equal to plus 1 equal to 0. This is equation number 1. Now in the f minus 3, you will find out, if you will put up this value, you will find out the equation 3a minus b plus 5 equal to 0. That is the equation number 2. So you are having one is a plus b equal to minus 1, and second is 3a minus b equal to minus 5. You are seeing is a minus b and minus b. You add right hand side, 3a minus b plus a plus b minus 5 plus minus 1, b get cancelled, 4a is equal to minus 6 sorry, this is minus 5 you will get, so it will be plus 5, so this will be plus 5, and here you will get a 4. So a is equal to 1. Apply the a value here, you will get a value of b. So that is what is another thing, and similar thing can come. What must be subtracted is added, what must be subtracted. Then you see this equation, what is the degree, below 1 degree, you do that, split the thing or factor again and solve in this manner. So that is what is all in the factor theorem. Other time, while I was making the video for the remainder theorem, at that point of a time we have studied the concept of integral root theorem and sorry, we studied the concept of the integral root theorem and rational root theorem. So basically this thing is coming under this factor theorem. You can do the factorization using that. I will quickly cover. Under the integral root theorem, like what you have to do, I will just take the example here. If suppose your equation is given fx is equal to 2x cube plus 6x square minus 4x plus 5. So how you will identify whether the integral root theorem or a rational root theorem will be applicable on that? If the factor or coefficient of a highest degree of the polynomial is other than 1, then you will apply rational root theorem. Rational root theorem, it will be B upon C. Now the B upon C will be your answer. So how you will identify the B upon C? The value of the B will be factor of 5. Factor of 5 will be plus minus 1 plus minus 5. And value of C will be factor of 2 plus minus 1 plus minus 2. And value of B upon C will be plus minus 1 upon plus minus 1. So it will be plus minus 1 plus minus 5 upon plus minus 5 is plus minus 5. Then plus minus 1 upon plus minus 2 is plus minus 1 upon 2 and plus minus 5 upon 2. So that is how you will find out the value, and after that you have to do a trial and error method. First find out the value of f1, then f minus 1, then f5, then f minus 5, then you have to find out the how many factors are there for this equation. How many factors will be there for this equation? Since it is highest degree is 3, so there will be maximum 3 factors. So you can go only up to the place where you can find out the highest degree of the factor. This rational root method or integral root method is, yes, you can do that, but sometimes you have to use the splitting method in between, because when the high degree of the equation is there, x raised to power 4 or something, then it is always advisable to use the other method also, because with the integral root theorem or rational root theorem, it is not possible to really find out all the factor. So first factor you can find out by dividing, and then onward you can find out the other factor. So that is what is all about in this polynomial equation. So I hope the video must be good for you and you'll do good in your exams. Thank you.